Going to start the meeting. All right. Good afternoon, everybody. I hope you are understanding the stuff that we're doing in geography this year. I'll be taking you for geography this year, regardless of which school you are at. But you're supposed to be joined in the correct Google Classroom because the notes and the work is going to be different. However, the discussions are going to be the same. Okay, my name is Mr. Mapedza, and then let's get started. All right. Last week I gave you notes on your lesson one, and this was your lesson one, right? Lesson one was structure of the atmosphere. So basically, what I did is structure of the atmosphere is not actually on the ATP. So it was more of an introduction of what's the things that you're going to be dealing with, so that you understand where it's coming from and where it's going, right? So the definition of an atmosphere is it is a thin layer of gases that surrounds the Earth. The amount of gases in the atmosphere decreases as the distance from the surface of the earth increases. So this means that the higher you go, the thinner it becomes as you move away from the surface of the earth. So that is the definition of the atmosphere. So the atmosphere has four layers, which is the thermosphere, the mesosphere, the stratosphere, and the troposphere, as you can see on your screens right now. And then each particular layer is described in the following slides. Like, for example, the troposphere, it is the closest to the Earth's surface, where where weather where all weather conditions occur. All right, so we're actually living on the troposphere right now. So it's the lowest layer, average depth is 15 kilometers, and I hope you read those notes. Then the next one is the stratosphere, where the protective ozone layer floats. So the stratosphere is basically the one that protects us, that contains the ozone layer that protects us from dangerous UV rays that come from the sun. It is the second layer below the mesosphere. Average depth is 40 kilometers. Negative lapse rate contains ozone. Ozone forms a protective layer shielding life on Earth from the sun's harmful ultraviolet radiation. So this means that if you don't have the ozone layer on Earth, people won't survive because of the heat that comes from the sun. And then we have the mesosphere, where meteors burn up. That is the third layer below the thermosphere, average depth of 30 kilometers. Temperature decreases with increase in height, and that is the mesopause. Right, then the last one will be your thermosphere, where the temperature rises yet feels cold. Layer furthest away from the Earth, average depth is 80 kilometers, absorbs many harmful X rays and ultraviolet rays from the sun. Okay, right. I hope everybody downloaded the textbook that I sent to you, because you're going to be referring to that textbook for most of the diagrams. Right. You're supposed to draw this in your book after the notes. I hope you drew it after you wrote those definitions for the different layers that we have. Right, the change in temperature. The atmosphere is divided into four layers according to temperature. And then when you look at the bottom here, that is the troposphere where we live. And then the ozone layers there just above it, so that it protects us from the harmful ultraviolet rays. And then we have the stratosphere, the mesosphere, and the thermosphere. So you guys are supposed to draw this in your books so that you have it in your notes whenever you need it. Right. These activities, I'm going to give you more time to do them. So I think you're going to do these two activities during this week, because I understand that you didn't have textbooks and then you couldn't do them. So you're supposed to do these two activities in your notebooks after the notes that you just wrote now. Ne? All right, let's move on. Let's go to the textbook and see what's happening there. Right. So if you want a clear picture of what we were speaking about, this is the structure of the atmosphere. Ne? So this is on page 82 in the textbook that I sent to you today. So you write those notes that I gave you, and then you draw this diagram there. This one is much more clearer than the one that you had in the other one in the slides. Ne? And then we have the definitions again, but the ones that are in the notes are much more detailed and much more specific. All right, as you move on, this is where we are in the textbook. Those are the two activities that you're supposed to do. Activity two and activity one is further above. I think it's on page 80 or 79. All right. Composition of the atmosphere. The atmosphere is made up of gases, solids, and liquids. These substances are essential for life on Earth. Right? Gases, we have nitrogen, oxygen, and argon. and those are the percentages that they have that make up the composition, that make up the atmosphere, the gases in the atmosphere. Right, as you can see, there's a picture there. We have nitrogen, which is the most dominant gas in the atmosphere, and then we have oxygen and argon. So these percentages actually allow for people to live on Earth. Right, about 1% of the gases in the atmosphere are gases which exist in a variable amounts, such as carbon dioxide, helium, ozone, water vapor, carbon monoxide, methane, nitrous oxide, and sulfur dioxide. We call some of these gases greenhouse gases. Right. The point that we wanted to get to is the greenhouse. Right. When we're talking about the greenhouse, okay, let me just finish the statement. Because they absorb radiation and this assists in heating the atmosphere. You learn about this in chapter 2. Right. A brief explanation. When we talk about greenhouse, we're talking about how heat is trapped on Earth and can't escape. Like, for example, if you see, let me just open an example of a greenhouse, then you can see what I'm talking about. Uh, all right. A greenhouse is more like a plastic house that you have built for plants again. So when you build a plastic house for plants, this means that during the day, as the sun is shining, it shines upon that plastic, and then heat is transferred into that through that plastic into the plants, and then it is trapped underneath the plastic. Right, so when it's trapped underneath the plastic, this means that that heat can't escape. So when it's nighttime and the temperatures drop, the heat that has been trapped throughout the day is used to warm up the plants that are inside. So usually when we have during the winter and we have plants that cannot survive the low temperatures, people build greenhouses, and then during the day when the sun is shining, the heat will penetrate and is trapped underneath the plastic or the glass, and then the air inside that particular room is warm, and then during the night it can be used to heat um, the plants that are protected, that are underneath that particular that are in that greenhouse. Okay, right. So what we're going to look at is a process associated with heating of the atmosphere, factors that affect the temperature of different places around the world, latitude, altitude, ocean currents, distance from the oceans, the greenhouse effect, global warming, the impact of climate change on Africa and its environment and people. So now we're looking at the greenhouse effect first. Okay, the greenhouse effect. A greenhouse is a glass house that protects us, that people use for growing plants. The air inside a greenhouse remains warm because it traps heat. This means that people can grow plants in the greenhouse even if it's cold outside. Right? The figure below is this one that you've seen right now. So that will illustrate what I'm talking about. Right. Let's go further. So the greenhouse effect is basically how the earth is heated by the sun, and then that heat that is penetrated through the four layers of the atmosphere passes through and reaches the bottom and the surface of the earth, and then is trapped and can't escape. So that is the greenhouse effect of the atmosphere. Right, let's look at how the greenhouse effect of the atmosphere works. Much like a greenhouse, the atmosphere allows shortwave radiation, short waves of insulation to move through the atmosphere and heat the earth, but absorbs the long waves of insulation and terrestrial radiation. This traps heat and keeps it in the lower layers of the atmosphere. Figure 2.20 Figure 2.20 shows the greenhouse effect of the atmosphere. Now, just now I spoke about how the sun is used during the day to penetrate through a plastic or a glass house, and then the heat is trapped inside and can't escape. So the same particular process happens when the sun in outer space, this one, penetrates through long wave radiation and then goes through the four layers that we spoke about: the mesosphere, the thermosphere, the stratosphere, and the other one there, the fourth one. And then this heat goes through those four layers, and then it is absorbed on the Earth's surface. This is during the day. So the sun is shining throughout the day since 6 a.m. in the morning until maybe 7 p.m. if it's in the summer, 7 p.m. or 4 p.m. or 5 p.m. during winter. Now, during the time that the sun is shining, the heat is going through the four layers and then it is trapped, it is absorbed on the Earth's surface. Now, when the sun goes down at night, this heat is trapped underneath the four layers and cannot escape. These are the arrows here. So, this atmosphere around the Earth is warm, creating a greenhouse effect around Earth. Right? We call gases that absorb and trap the long wave radiation greenhouse gases. So we spoke about the gases that we have in the atmosphere. We have nitrogen, argon, and carbon dioxide, I think. Right. Those three gases are the ones that are heated and then they trap the heat underneath the four layers of the atmosphere. So this means that the temperatures on the surface of the earth will increase because the heat is trapped and then constantly it is heated during the day as the sun shines uh, on the earth. Right. Greenhouse gases are mainly water vapor, carbon dioxide, but other pollution gases also absorb long wave radiation. Right. Let's look at the definition of the greenhouse effect. The ability of the atmosphere to trap heat and remain warm. So we spoke about how the heat is trapped and how it is absorbed on Earth, right? The natural greenhouse effect of the atmosphere keeps the Earth's temperature above about 15 degrees Celsius higher than it would otherwise be. So this means that if we did not have this greenhouse effect on Earth, the temperatures would be lower than 15 degrees Celsius. I think everybody has noticed that 15 degrees Celsius is quite a low temperature. Ne? So we need these gases to keep our atmosphere warm so that we can survive and our plants can grow, right? Without the natural greenhouse effect of the atmosphere, nights would be bitterly cold, like they are on the moon. Okay, there's no gases around the moon, which means that all the heat that is accumulated by the moon is released as the sun moves away. The natural greenhouse effect is necessary to sustain life on Earth. Without it, people, animals, and organisms would not survive. Vegetation will not be able to grow, and there would be no food. So we need this greenhouse effect on Earth. All right. Um, let's see. The next thing that we're gonna look at. Okay, are there any questions? I'll move on to the next topic. Okay, Jess, you want to ask something? Okay, then if there are no questions, let's carry on then. Right, now we're going to look at the processes associated with the heating of the atmosphere. All right, let's see where that is. Electromagnetic spectrum. Right, processes associated with the heating of the atmosphere. Now, uh, all the heat and all the energy that is accumulated and used on Earth comes from the sun. So basically, everything that we have around us that makes us survive on Earth comes from the sun because that is the main source of energy and heat that supplies Earth. Okay, so the sun will send shortwave radiation and that will heat up the Earth. And then long wave radiation will escape, but not that much, from the sun. So we are going to look at how this heat is transferred to the earth from the sun. Right. We have what we call the sun's electromagnetic spectrum. The sun transmits energy invisibly in the form of waves. We call this radiant energy. Radiant energy is radiated in different wavelengths. Figure 2.13 shows that a wavelength is the distance between the crest of two waves. The crest of a wave is the peak of the highest point of the wave. All the waves of the sun's energy travel at the speed of light which is 300 kilometers per second. So the movement of heat from the sun to the earth is shortwave radiation, and then it moves in waves, and then it is radiant energy. Okay, so radiant energy is moving invisibly in the form of waves from the sun to the earth. And then a wavelength is the distance from the crest to crest of two waves. So if you have two waves, this is the wavelength, which is the distance from one crest to another. Okay, right. The electromagnetic spectrum of the sun is the distribution of the sun's radiation according to wavelength. Okay, so the movement of energy from the sun according to the waves is what we call the electromagnetic spectrum of the sun. I hope it's making sense. Right, so as these waves move, we have different ways in which heat can be absorbed on Earth. Right, we have insolation, which is incoming solar radiation from the sun. We have solar constant, the amount of solar radiation that reaches the tropopause. We have reflection. Radiation strikes a surface but is sent back into the atmosphere without being absorbed. And then we have absorption. Gases in the atmosphere take in radiation from the sun. Scattering, radiation bounces off particles of dust in the atmosphere. Okay, so let's look at insolation first. We call the sun's energy that passes through the Earth's atmosphere insolation in the form of incoming solar radiation. Right, when we say incoming, we're talking about how the heat is emitted. Just go back quickly. Sorry, I lost the page. I will go back there quickly. Should be up to 87. So page 80. Right. When we talk about incoming solar radiation, insolation, we're talking about how the sun will give off heat, and then this heat as leaves the sun. As it leaves the sun, it is incoming to the earth, and then it is called solar because it's coming from the sun, and then it's moving in radiation, shortwave radiation towards the earth. Hence, we have insolation, incoming solar radiation. Okay, and then there's the explanation right there. The sun emits a short and long wave radiation. Most of the ultraviolet rays and X-rays are absorbed in the thermosphere and stratosphere. This is why temperatures are so high in these layers. Right, so we have insolation, which is one of the type of radiation that happens from the sun. Right, let's look at that diagram there. This is the insolation, which is our solar constant. And then we have reflection, we have absorption, reflection, scattering, and then 47% of the solar constant reaches the Earth's surface. So out of 47, out of 100, only 47% reaches the Earth's surface, and the other 53 is lost in the atmosphere as it moves from the sun to the Earth. Okay. Right. Let's stop the heating of the atmosphere by the Earth. All right, let's go back to the notes. Right, so this is lesson one that you guys did. It was more of an introduction so that you understand the layers of the atmosphere, and then you know what we're talking about. And then today, you guys, I gave you a lesson two. Let's see where that is. Lesson two. Right, I'm just opening lesson two so that we can go through it, and then you guys can understand what the lesson has. I want you guys to ask questions. Feel free to talk about what you don't understand so that we both, so that I can help you, and then we all know what's going on as grade 11 or grade 10. Okay, all right, I'm just opening up lesson 2 so that everybody can see what's going on there. All right, let's go back to Zoom. All right, lesson 2. Right, can everybody see lesson 2? Right, for lesson 2, this is what I gave you today. What is in greenhouse gases? That's a typo right there. Right, gases in the atmosphere that absorb long wave radiation, gases that trap heat in the atmosphere. That's what I just explained right now. And then condense. The process is supposed to be condensation. I'll fix it. The process in which water vapor changes state from gas to water. And then composition of the atmosphere. We spoke about that. And then chemical comparison, we just did that now. Gases, permanent gases in the atmosphere, variable gases, solids, liquids, right? Leave out this activity because you're gonna do activity 1 and 2 this week. All right, so lesson 2 was about the greenhouse effect, and then I just explained that. Yeah? All right, let's look at lesson 3. See what's happening in lesson 3 so that we can just be ahead and then we know what's going on in lesson 3. Right, importance of gases and the atmosphere. That's lesson 3. That's something we used to do. Importance of gases. We spoke about this where we said the gases that we have are the ones that trap heat from the sun, and this allows us to have different weather conditions, and then this allows us to have life on Earth. And then the atmosphere acts as a blanket around the Earth, protects us from extreme heat. All right, so that's quite short. So what I want you guys to do is after you finish lesson 2, you guys are supposed to go back to your textbook. Okay. After you finish lesson 2, tomorrow I'll post the what you call it, the instructions on what you need to do in on from your textbook, and then from that textbook we'll see the diagrams that you need to draw in your notebook, and then we carry on from there. Right. So you're supposed to do activity 1 and 2. So that's today and tomorrow, and then we'll mark them on Wednesday, and then we'll just carry on from there. Is there anybody who wants to say something before we end the lesson? So the lesson is actually ending in 10 minutes. So this is your time to actually say something, and then we can discuss what you don't understand. Can everybody see me? I'm waiting for questions now. So you can start asking questions about the stuff that we spoke about. We have 10 minutes left, and that will be the end of the lesson. If you want to ask something, ask now. If there's something you don't understand, if you didn't get a textbook, or if you didn't understand what we spoke about just now. Right, if you look at your ATP, let me just open the ATP while I'm waiting for people to ask questions. All right, let's see. All right, I'm waiting for people to ask questions.
Sir,
Yes.
can you please post the textbook on Google Classroom?
Okay, I'll do that. I posted it on WhatsApp though.
Yes, sir.
Yeah, you can download from WhatsApp.
Oh, okay, sir.
The WhatsApp is much easier than Google Classroom because Google Classroom is going to tell me that the document is too big to post. But I'll try. I'll post it tomorrow on Google Classroom as well. But it's there on WhatsApp
Oh,
right now.
okay. Thanks, sir.
All right, sure. Anybody else? Right. So if you go to your ATP, you will see that we did greenhouse effect and we did global warming. And then we're still going to look at processes associated with heating of the atmosphere, factors that affect temperature of different places around the world, and the impact of climate change on Africa's environment. So we still have a lot, but we're going to cover this work this week because we're going to be having Zoom lessons every day. Right? Any more questions besides the textbook stuff? I hope you understood the stuff that I'm giving you in the notes, and these Zoom meetings are very useful to you. All right then. If there are no questions, I'm gonna end the meeting, and then we'll meet again tomorrow. I'll send an invite. So tomorrow we're gonna have. If I'm not busy at work tomorrow, I'll have one lesson in the morning for SPHS and one lesson in the afternoon at 4 p.m. for HP. But if I don't have a lesson in the morning, this means that everybody can join this lesson in the afternoon for everybody's benefit. Okay. All right. Thank you for joining. I'll see you tomorrow.